Good morning, good afternoon, everyone. This is Miss Matei and Miss Lavnika, and we will be talking about the length of a line segment. We will start our discussion by looking at a specific example. We want you to find the length of the line segment AB that joins the point A of coordinates 2 and 1 and B of coordinates 6 and 4. The first thing that we wanted to do, we wanted to pause the video and try to figure this out on your own before you continue watching us. Okay, so what do we do?
Well, I plotted the points A at 2 and 1 and B at 6 and 4. And one thing that crossed my mind was if I would construct a right angle triangle above or below the line segment, I can simply calculate length of AB as a length of hypotenuse in a right angle triangle, and I know how to do it.
How do you know how to do it? Because my problem is I don't know how to find the length of this segment and the length of this segment over here, the horizontal and the vertical segment. How do I do those ones?
Well, if anything, I can simply just count the squares, or I can look at the y coordinates of point A and B, which is 1 and 4, and find the difference between two of those coordinates. So 4 minus 1 will give me 3.
Okay, so you basically told me that I can do this as the difference between the y coordinate of point B minus y coordinate of point A. Is that correct?
Yes, that's right.
Okay.
And the same thing you would do for a horizontal distance.
Okay, so if I count squares, I know it's 4 squares.
And if you subtract your x coordinates, that means 6 minus 2.
It's 6 minus 2,
which is 4.
Okay, so now I know I can apply my Pythagorean theorem, right? AB squared is, if let's name this point C, this is nothing else but AC squared plus BC squared. Is that correct? This is nothing else but Pythagorean, right?
That's correct.
Okay, so now I know AB squared is 3 squared, or in other words, 4 minus 1 squared plus 6 minus 2 squared. I showed here how I got my numbers 3 and 4, so it's 3 squared plus 4 squared, but these numbers seem very familiar to me, right?
Of course, they are Pythagorean triplets, so...
Oh, so look how lucky we are. AB is square root of 25, so it is 5.
That's correct.
So I found, exactly as you told me, the length of AB. Now, can we take the same process and apply it in general for any 2 points A and B?
We should. And it should not be any difference now without the numbers as we did it with the numbers. So point A has a general coordinates x1 and y1, and point B has general coordinates x2 and y2. Simply construct a right angle triangle above or below the line segment.
Okay, so I'm gonna need
That's
this
right.
vertical distance over here, and I'm gonna need this horizontal distance over there, correct?
That's right.
Okay, so the blue distance is?
The blue distance or vertical distance is y2 minus y1.
Okay.
And the green distance is x2 minus x1.
Okay, so again, I have my Pythagorean. Let's apply it.
That's right. So AB squared is equal x2 minus x1
x2 minus x1
squared,
right?
y2 minus y1 squared.
Okay.
So if we want to figure out the length, we need to square root both sides, and therefore the right side will be square root of x2 minus x1 squared plus y2 minus y1 squared. And hence we discovered the length formula of a line segment between two given points A and B.